listening at these ports, you can add another switch. So the switch is, if you want to do this on your computer, you can type netstat space -A and O. I'll put that in the notes, and I'll put that in the chat. Okay, so let me put this in the chat. All right, let me explain what these three switches do. A includes the listening ports. N says don't try to resolve the name for the foreign address. So it goes into DNS and it tries to look up all these IP addresses. So the N says don't look up the IP addresses. The O says tell me the process that is using that connection. So let's do netstat A and O. And now I'm going to scroll up. Here are the connections that are established between me and this port and these remote machines. And here, this is the PID, the process ID that's using that connection. So you can see here, this is the PID column. So if I scroll down, I can see who's making these connections. So this is 11,728. So let's open Task Manager, sort by PID, and I'm looking for 11,728. Oh, nothing wrong with that. 11,700 and why does it keep going? Here we go. OneDrive. So this is a connection I have for OneDrive. Then the next one here is 19,720. Do it this way. That's Teams. So all of these connections are Teams. 20,860 is my browser, MS Edge, and it knows to connect at 443. 24,536. Word. So Word has some type of connection also to this machine. So that's how you can go and figure out who's who. Now, if I look at, that's what's connected. Now, this is what's established, this is what's listening. So 135, so if you came to my house, knocked at door 135, the person who would answer is PID 1420. So I'm going to scroll to PID 1420. And you can see that's SVC host. Well, if we remember from day one, we can figure out who SVC host is by right-clicking and clicking Go to Service. And you can see that is the RPC endpoint mapper. So port 135 is for RPC. 808 is being listened to by 7,040, or 7,040. So let's see who's listening at that port. That is one app. IGCC Win Service. I don't even know what that is. But this is how you can go through and see who's listening at what port. Does this make sense?
Yes, yes. It's
okay. Let's take a network trace, and you're going to be able to see this in real time. So what I want you to do is hopefully that everyone download the Netmon installer. Did everyone download Netmon? Okay, let's go ahead and install it. So you can take the defaults on the install. Okay, so go ahead and run it, and then hit next. you're gonna hit install. Mine says modify or repair because mine's already installed. Next, install. That's it. You take the defaults. Let it finish the install. Mine's doing a repair, and it's done, finished. So mine is, well, I'll say that. Okay. Is yours still installing, or is it already installed?
Installing.
Still installed.
Okay.
Installed. Yeah, still installing.
Okay.
To? Ay, hindi pala.
Okay, while it's installing, let's talk about TCP for a second. Okay, I mentioned that TCP has a formal process to make the connection. So in my example, I went to my wife and I said, hey, Kayla, I want to talk. And I said that I sent her a message, so I need her to acknowledge she heard me.
YouTube? Hindi.
So there's a formal process, and I said it was called a three-way handshake. Well, this is the actual handshake.
Nilay mo na nagbabraw
So I sent a message to her saying that I want to synchronize. It's called a send, an S-Y-N. I want to synchronize with her. Because I sent her a packet, she needs to acknowledge that she got the packet and also synchronize with me. Because she said she wants to synchronize with me, I need to acknowledge her. This is why it's called a three-way handshake. It's a send, send, act. And now I can finally ask her a question. This is how TCP works. When we're done talking, I send her a fin and say, hey, okay, thanks for telling me about dinner. I'm done. And I can send a fin here. Because I sent her a packet, she has to acknowledge I sent her the packet. If not, I assume she didn't get it. So she has to acknowledge the fin. If she's done talking to me, then she may also send her fin. I will need to acknowledge. If you do not get if I send her a packet, hey, what are you doing this weekend? And she does not acknowledge it, I assume she didn't get it, and I will send it again until she acknowledges it, and I will send it again. That is called a retransmit. When the other side does not acknowledge that they got your question, hey Kayla, if she doesn't acknowledge, yes, I'm going to say, hey Kayla, again. And if she still doesn't hear me, I'm going to say, hey Kayla, again. I do that a lot with my kids. It's like, I got to get their attention. Hey Lauren, I need them to acknowledge they heard me, right? To get their attention. So I'm not going to ask them the question or what I want them to do until they acknowledge that they heard me and they're paying attention. And if they don't, then I'm going to keep calling their name until they finally do acknowledge me. It's the same thing with TCP. Okay, so this is how a conversation starts. It starts with a three-way handshake. Send, SYN-ACK, ACK, and a conversation finishes with FIN, FIN-ACK, ACK. Sometimes there's 4 here. Now, if something goes wrong in the middle of a conversation, and let's just say we get mad at each other, or one person stops responding, and I retransmit, I call my wife's name 3 or 4 times, and she never answers, then I may reset the connection. Maybe we're talking, and I say, hey, she says, hey, I say, what's going on? I want to talk to you. Okay, I want to talk to you too. Okay, what do you want to talk about? Well, what are you doing this weekend? Well, I think I'm going to start going to, and then all of a sudden, I don't hear anything else. It's like a bad cell phone call. At some point, one of the sides is probably going to hang up or get disconnected. No one said goodbye. It's just all of a sudden the conversation dropped. That is called a reset. When the conversation ends in the middle of it, and then there's no formal, okay, I have to go. I'll talk to you later. Okay, have a good day. Bye. That is a polite way to end the conversation. That's how we want it to end. If your call gets dropped, or you're talking and the other person doesn't hear you, and you keep asking, hey, can you hear me now? Can you hear me now? Can you hear me now? At some point, you're going to terminate that conversation and just hang up. They'll call back. And that is a reset. So the 2 things we look for in a network trace that can indicate problems are retransmits, resets. These 2 can indicate a problem. If a retransmit happens every once in a while, it's not a problem. TCP takes that into consideration. If it happens too much, it can cause the conversation to slow down. If you have to keep asking the same question over and over or repeating yourself, that can cause the conversation to slow down. So that is something we look for, retransmits. And resets are also something we look for because that can indicate that there was a problem with the communication and one of the parties terminated or hung up the conversation. So these are the 2 things that I typically look for. I also look for delays. If I send a request and a lot of time goes by before I get the response back, and this is like 7 seconds, well, that could be a problem too. Because if I'm an application and I send a request to update the screen, and it takes 7 seconds to get the response back, my screen may be hung for 7 seconds if it's waiting on this data to return. So I also look for delays in responses to questions. I'm going to show you how to do all of these. All right, is Netmon still installing or is it done?
It's done, Mike. It's done.
Done. Okay, let's take our first trace. So what we're going to do is this. This is very important. You have to run Netmon as an administrator. So Windows key, do a search for Netmon. It's going to come back with Netmon 3.4. Right click, run as admin. If you do not run it as admin, you will not be able to collect this trace. It's not going to show you any adapters. So I'm going to right click, run as admin. It says, are you sure you want to? I say yes. This is Netmon. There are a bunch of screenshots about Netmon. I'm not going to show you all these screenshots. You can go back to the slides and look at the screenshots and see what all this stuff means. You can apply the same knowledge to Wireshark. So if you want to use Wireshark instead of Netmon, you can download Wireshark and use Wireshark. The same principles right here apply to Wireshark. The same ports, all that is the same. Networking is networking. Okay, down here at the bottom left, it says what network do you want to record the traffic on. It even tells you the IP addresses. I'm gonna leave all mine turned on, and I'm gonna hit new capture up at the top left. It's gonna bring up this screen here, and all you have to do is hit start. And that's gonna start recording all the network traffic on your machine. You should see data start to pop up here. So now what I want you to do is I want you to load a web page. Any web page in any browser. You can use Chrome, Edge, Internet Explorer, Firefox, it doesn't matter. Okay, then we're gonna hit stop after we load the web page. All right, now we've collected our first trace. One of the reasons why I like Netmon is because it breaks down the conversations by process. So I can click on any one of these processes and see what it's talking about. But before we do that, let's look at some basic stuff. So DNS allows me to look up IP addresses to names. So I'm going to come up where, so at the bottom here, it tells you I've captured 17,962 packets. And I'm displaying 17,962 packets. That is a lot, 18,000 packets in about a minute. I don't want to look at each one. So what I want to do is I want to set a filter. So let's filter and look at DNS and see if we can see the name queries. So what I'm going to do is I'm going to click on load filter, and then it says standard filters, and then I've got a bunch of different filters that I can use. One of those filters is DNS. So you can select DNS and then put DNS all name query. And then hit apply. And that will filter the 18,000 of my packets and just show the DNS request. So on your machine, I have taken it from 17,962 to 202 packets being displayed. So now what I'm going to do is I have IPv6 and I have IPv4. I'm going to grab an IPv4 address and we're going to take a look at it. So I can see my IP address right here. It's 192.168.5.65, and that is the source. So I sent something to 5.254, which is my DNS server. Now, to make this easier to read, so I don't have to remember the IP addresses, I can right-click my IP address and do create alias for source address. And I can call this John. So now every time my IP address shows up somewhere, it says John. I can also come to the other one and create, and I can call this my router /DNS. So now, anytime I look in the trace and I see John, I'm going to know, oh, that's my machine. Anytime I see this, so I don't have to remember the IP addresses. I'm going to add one other thing. So I'm going to find John, so my machine, in the source column, and I'm going to right-click the line where it says John, and I want to add the source as a color rule. So I right-click where I'm the source, add source as color rule, and now I can select a different color. I like to change my background color. So I'm going to select background color. I just click the white box, and I like to select the light blue. And I'm going to hit OK. And OK. And now, you're going to see anytime I send something to someone, it's going to highlight that in blue. Now I can easily see when I'm sending packets. Any of the blue ones is me sending to another machine. All right, let's take a look at this DNS query that I made. So I'm going to scroll up, and I'm going to click on this first one here. So this is me sending to my router that also does DNS. And when I click on it, I can look over here at the description, and I see that it's a DNS query, and there's an ID that's associated with that query. And that ID is 41DE. This is how I keep track of what questions I've asked. Now, if I scroll over here, you can see this query is actually looking for assets.msn.com. So I asked my router / DNS server, hey, who is assets.msn.com? I'm going to look for a DNS query ID of 41DE. So I'm looking down, looking. Here's 41DE. This is the response to my question. And you can see it's coming from the router. So this is me going to the router. This is the router coming back to me. And I matched up the IDs. So I know that this response is to my question for assets.msn.com. And the answer it's giving me is 23.213.205.24. That's the IP address. It's actually giving me multiple IP addresses. All right, this is the description field. Let's look at the frame details. This is very similar to the TCP/IP protocol suite. I'm going to bring this slide back up. So you've got, but it's inverted. So you've got Ethernet, IP, doesn't want to do my arrow. Ethernet, IP, transport layer, and application layer. These are the layers that we talked about. What happens at each layer? My ports are done at TCP layer. My IP address is done at the IP layer. My MAC address is done at Ethernet layer, and my data, my application data, is done at the application layer. So, as I'm looking at this trace, I don't care about the MAC address, I don't care about the IP address, I don't care about the port, but I do care about, in this case, the application data, which in this case is DNS. Now, DNS uses UDP, so that's why you see one packet for the question and one packet for the answer, because it's using UDP. There's no handshake, there's no synchronize, there's no send, there's no ACKs. It's just question, answer. So let's expand DNS, and this is the application data that was sent. It had, or this is the response actually that came back. Let's click on the question. So here is my question. So this is from me to the server, and it says, hey, I have one question. There's no answers. And my question is, who is assets.msn.com? And I can expand this, and it tells me this is an A record that it's looking for. And the query ID is 41DE. So I come up here, I find my response, and this is the response from the server. I'm not looking at any of this stuff up here because it's not relevant to my troubleshooting. Here's the query ID. It repeats the question. It says, hey, this is the question you asked, and I have 5 answers for you. And here are the answers. So if I'm going to the wrong website, or maybe it's taking a long time to load a web page, or maybe I can't access a web page, Maybe because DNS is broken. And you can grab a network trace to see exactly what's going on with the traffic. All right. Does this make sense so far?
Yes.
All right. Let's take a look at a TCP connection, and then we'll break for lunch. So up at the top left, so I'm going to remove my display filter because I'm done looking at DNS. So I'm going to click remove, and it's going to show me my 17,962 frames. I'm going to go over here, and I know that I launched MS Edge. So I'm going to simply click on MS Edge. And that is going to filter and just show me packets from MS Edge. Now, there's two MS Edge processes. I don't know which one's which, but this one only has 43 packets, so I'm going to select the other one because I loaded multiple pages. Okay, so this has 1,366 frames. So I filtered all my traffic just on MS Edge, specifically process ID 20860. I'm going to expand MS Edge, and this shows me all the IP addresses or all the pages that my browser was talking to. So this is Joseph and Martin and John and Albert, Jerson and Daryl. This is everybody I'm talking to. So let's pick one of these out. So if I take the first one and I expand it, let me look. I'm going to expand these. Here's one. So this is the first one. You can see I'm talking to Albert, and these are the ports that I'm talking to Albert on, 443 and 57,513. All of these are 443. I'm going to try to find one that's not 443. These are all encrypted. I'm trying to find one that's not. Jeez. Everything nowadays is encrypted, which is good and bad. Well, you can still see encrypted traffic. So this is encrypted traffic. You can still see it. You just can't see the actual data. I'm going to try to find one that has port 80 on it. None of these are doing 80. Hold on. Nothing's using port 80. It's all encrypted. Let me, we'll go ahead and break for lunch. I'll do a trace and I'll get, so everything, I loaded 2 pages. I loaded MSN and I loaded this news page. And this is, it's all, as you can see, it's all HTTPS. So it's all encrypted. You can see stuff. You just won't be, we won't be able to see the GET requests. But I want you all to be able to see that. But let me show you the handshake and then we'll break. Okay, so here is the conversation to this machine here, 88.128, and these are the ports. This is a 3-way handshake. So this is me going to that server, and you can see the S stands for synchronize. The server responds back to me with an A, which is an acknowledgement to my synchronized packet that I sent. Every time I send a packet, it has to send an acknowledgement. It also wants to synchronize with me. So it sends its own synchronize, and because it sent me a packet, I have to respond. So this is a 3-way handshake. Send, act, act. No questions have been asked at this point. How do I know that? If I look over here, I can see there's payload length, that's the application data, is 0. No application data has been sent, just packets. So now I start sending encryption information. So if I click on this next one, you can see the payload length is 517 bytes, and it starts to set up the encryption for TLS, client hello. And then it'll go back and forth while it sets up the encryption. After the encryption is set up, then the data will look like this. It's just encrypted. I'll try to find a trace for us after lunch that it does not have encrypted data, so you can actually see what the data looks like. But that is a three-way handshake, and that's how it starts. Any questions on this networking stuff so far? We're not done, but any questions so far before we break for lunch?
John?
Yeah.
Just a quick question.
Yeah.
Could we use this as monitoring or because we have some users that are
Paano napapalitan yung pangalan?
connecting to our VPI. And they said they're always
Ito yan, di ba? Ito to, 1043.
disconnected to the VPI. Is it possible that this tools can be used?
That one? Yeah. I would definitely use this tool. The problem you're going to run into is that